Now we'll discuss about the pigeonhole principle. Okay, so I told you in the counting principle, fundamental counting principle. Actually, we have permutation, combinations, pigeonhole principle also in the syllabus. Like pigeonhole principle is the very, I can say that it's not too much difficult thing, but the thing is that the type of questions actually asked, type of question, sometime it will means you will not find it means sometime it will not find it whether it can be solved using the Python principle or not. So like simple, it's a very basic simple principle, but the type of questions that is asked in the paper actually means I don't know whether means in the exam if the questions will ask whether you will think whether these questions can be solved using the Pigeonhole principle or not. But I think questions from the Pigeonhole principle is asked every year, and obviously you can refer to the paper to find the questions, but I will explain the Pigeonhole principle. So let's discuss about this pigeonhole principle. Okay. So let's understand with the help of example. So let's suppose that okay. So let's suppose that we are having a 20 pigeons. Okay, there are 20 pigeons, and there are so but there flock of 20 pigeon files into a set of 19 pigeons to roost. Okay, so like let's say this particular thing, three, uh, three, then three. Okay, so it is saying that there are 20 pigeons files into set of 19 pigeon holes to roast. Because there are 20 pigeons but only 19 pigeons roast, at least one 19 pigeon must contain two pigeons in it. So like let's understand that there is a I think thing, let's say there are a box. Okay, it's a box is there. Okay, so one, two, three, four, five, six, seven, eight. Let's say there are total nine pigeons. Okay, and we have to keep those nine pigeons into eight boxes. Okay, so let's say randomly you choose a pigeon and just distribute it into a some box. So we are sure that at least one box is there that is going to contain a means there's going to contain two pigeons. What it does mean that let's say we have put in pigeon 1, pigeon 2, pigeon 3, pigeon 4, pigeon 5, pigeon 6, pigeon 7, pigeon 8. Now where will keep the ninth pigeon? We are going to keep it into the any of this particular hole. Okay. So it means that when you have let's say you have a let's say k plus one something, and you have to keep it into k boxes. Let's say you have k plus one object, and you want to keep those into k object. It is sure that the one object will contain two object. One box will going to contain the two object. So like it may say that okay, let's say what do you want to say? It may happen that two or more than boxes may contain the two pigeons. Let's say something like that. If this is the box that we have, so we have to distribute the box. It may happen that some particular box contain three pigeons because three pigeons entered in that particular box. Yeah, this is correct. I am saying that at least the thing is about at least. Okay, at least two pigeons, at least one box will contain two pigeons, at least one box, or you can say at least one box contain more than one pigeon. Okay, so using this fundamental concept, this fundamental example of principle arise, this is called a pigeonhole principle. Okay, so we'll discuss the definition of the pigeonhole principle, and then we will see how to solve some particular type of question. But things that the simple fundamental thing is that let's say there are 20 pigeons and there are 19 box to keep them. So at least one, keep the word in mind, at least one box must contain more than one pigeon, must contain more than one pigeon. It may happen that obviously it may happen to more all the pigeons are in the same box, but obviously that is also true. At least one box will contain more than one pigeon. It's not likely that no box will contain more than. It's not true. At least one box will contain more than one pigeon. Okay, so what is the pigeonhole principle? If k is a positive number, okay, then k plus one or more objects are placed into k boxes. It is saying that you have k plus one or more object, maybe k plus two or k plus n, k, and you are trying to put those into k boxes. Then there at least one box containing two or more of the objects. It is saying that at least one box will be there that will contain two or more objects. This is true. You can think that this is in general true. Okay, this is in general true. If you are having k or k plus one or more, and you are trying to put those out into k boxes, obviously one will go contain more than one or two, more than two or more object. Okay, so this pigeonhole principle also called Dirichlet drawer principle by the name of scientist. Okay, so let's discuss some examples that is similar to this particular thing. Okay, so what is the examples? Among any group of 367 people, let's say in your school there are 367 people, there must be at least two with the same birthday. How this is going to be true? So, like in, let's say, we are considering the leap year also. So we know that there are 366 different dates in a year. So it may happen that someone is born on 1 January, someone on 2 January, someone on 29th February, 4th September, 29th September, 10th December. So total 366 possibility are there. So if 367 people are in a room, or 367 people are in a class or a group, it is almost 100% sure, it is 100% sure that at least two people, means I'm not talking about the at most, we don't talk about at most using the pigeonhole principle, we always talk about at least. At least two-person, let's say in the worst case, each one of the people have the different birthday. In that case also, it is 100% sure that at least two-person will have same birthday. Okay, this is 100% sure. So we don't talk about at most, so don't argue about ki, okay, it may happen that three or more person have the same birthday. It's true, it can be true, but we are not talking about the at most, we are talking about the at least. At least means come say come, at least one two person will be there which will have the same birthday. Okay, let's discuss about the other example. In any group of 27 English word, okay, there are 27 English word we have picked out randomly. So there must be at least two that begins with the same letter. So we know that in the English there are 26 different letter starting from A to Z. So if we put 27 letter, it is sure, it is 100% sure that at least two letters will be there, some two letters will be there that will contain more than, that will start from same alphabet. Okay, so how this is true? Obviously, you have 26 alphabet. You choose different word. All the word you choose different. So you choose 26 different word. But as soon as you pick the 27 word, it is going to is first letter. First letter is going to match with any of the chosen 26 word. So that is what I want to tell. This is what it means. Okay, so this is what it means. So I think this particular thing is clear. Just the thing is that you have to think in terms of the at least, not the at most. Think in terms of at least. Okay. So just talk about some more example. Okay. So the example is how many students must be in class to guarantee that at least two students receive the same score on the final exam if the exam is graded on a scale of 0 to 100. So it's, you can see that 0 to 100, if exam is graded, then what should be the number of students, so such that if two students will score, two students will receive the same score. Okay, so how to find this? This is simple. Obviously, let's say you choose first student, let's say he get 0 marks. Okay, then second student, let's say he get 1 mark. Then similarly, let's say you choose the 100th student to get the 100 mark. As soon as you pick the 101st student, means the 101st student, he is going to match the marks of some particular person. So if there are 101 students, it is sure that two person is going to get the same marks if it is talking about 100 marks. Okay, so this is one of the example. Some other example is that a function f from a set with k plus one or more element to a set with k element is not a one-one function. So we talked about the one-one function earlier. We saw that if we set a to set b, we were trying to talk about the one-one function. Then that particular function, number of elements in set A, okay, and the number of elements in set B, this particular thing set B should be more than set A. Okay, so how this particular thing is working? So let's see this particular thing. Okay, suppose that for each of the elements y in the codomain of y, we have a box that contains all the element of x. So this is just a sequence. This is if A and B are defining, and let's say there are k plus one element and there is k element. Then obviously some means, let's say you choose all the different combinations, all the different relation to all the k element. But for the k plus one element, it is going to relate to some element in B, which is already being related to some element of A. So in that case, it is going to be the many one function. It is going to be many one function because there are k plus one element and there is k element. Obviously, it should be like if A should have k element and B should have k plus one element, then it is going to be one one. But if A has k plus one element and B has k element, then in that case, it is not going to be a one one function. Okay, so you can just read this particular thing, how this particular thing explained. But the way I explained is this. Okay, so there is something called generalized pigeonhole principle. Okay, so what is the generalized pigeonhole principle? So the generalized pigeonhole principle tells you that if n objects are placed into k boxes, okay, so either it is talking about n object, not something like k plus one or k plus two. So thing is, if n objects are placed into k object, So if n objects are placed in the k boxes, then there are at least one box that will contain at least n divided by k. This is the floor object. Okay, what does this thing means? Just see this way. Among 100 people are at least, let's say there are 100 people are there. Okay, so it's saying that there are at least 9 people who are born in the same month. So how this particular thing is true? Let's say we have a 12 bucket. Okay, 12 bucket. 1 2 3 4 5 6 7 8 9, okay, 10 11 12, the 12 bucket. Okay, so you picked up a person randomly and put into one bucket because maybe he's born in the January or February or March or something like that. So you keep doing this particular thing, keep this particular thing. So like out of 12 bucket, you are going to get, each bucket will going to have, okay, so each bucket is at most going to have the 96, in total 96 element will there. Okay, it is saying that ki out of 100 people there are at least 9 people who are born in the same month. So how this particular thing is true? As soon as, okay, as soon as you start picking the 97th people, okay, so what you will put in some this element or this bucket or this bucket. So it is going to that ki nine of the particular person are going to born on the same month. Okay, so let's say you told ki, okay, it may happens that, okay, you asked that it may happens that ki, okay, so this particular thing is there. Okay, so what it is saying, it is saying that if 100 peoples are there in the there, then at least, obviously what is it, the n objects are placed into k boxes, then there are at least one box that will contain n by k object. Okay, at least one n by k object. So if there are 100 people and there are 12 month, obviously there are 9 people going to be there who are born in the same month. Okay, who are going to be born in the same month. Okay, so like questions like this can be asked. So let's see this particular second questions, and this question is interesting. It is saying that what is the minimum number of a student required in a discrete mathematics class to be sure that at least 6 will receive the same grade? Okay, if the possible 5 grade are A, B, C, D, E, F. So it is saying that total number of total grade are A, B, C, D, F. These are all the 5 grade. So how many students should be there in the class so that at least 6 students, not the one, not two, at least 6 students will receive the same grade. So we need to find the n such that this particular n by k is going to be 6. Okay, n by k is going to be 6. So what is k here? K is equal to 5. Okay, 5 bucket are there. So n divided by 5 is going to be 6. Okay, so obviously like at this point of time, how do you think this particular question? Just see it this way. Okay, the smallest in such integer is n. Okay, so it's saying that the minimum number of students needed to ensure that at least 6 students receive the same grade is the smallest integer n such that n divided by 5 is equal to 6. So you have to find out the smallest possible n, smallest possible n. Okay, this thing you have to keep in mind. So obviously let's say n by 5 is equal to 6. This is the floor. So what is the minimum n? Okay, so obviously let's say means like if you just choose here, what you can choose here, uh, okay, so you need to so you need to choose here such n's that is going to contain the this particular thing. So let's say n is equal to, we have the 5 grade. Okay, we have the 5 possible grade. Let's say we choose 25%. Okay, so obviously in the worst case, what we can do, 5% get this particular thing, 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 and 5% get this particular thing. But as soon as we picked the 26th student, we are going to get something. And what we are going to get something, we are going to get a student which will have either of this possible grade, and obviously our possible thing will be satisfied. Okay, it is saying, what is the question? At least 6 will receive the same grade. So obviously if you have the 25%, then yet in the worst case it happens that all the grades is occupied by 5 students, means 5 students are also getting a. But as soon as you pick the 26 student, you are going to get a student that is actually going to get this particular thing, like 6 students will receive the same grade. Okay, so n is equal to 26. So like you have to think in the terms of based on the basis of your intuition also. And this is the way actually you solve the questions using generalized Pigeonhole principle. But sometimes the generalized Pigeonhole principle will seem difficult, because questions like this does not like means it will looks like it means, obviously if you see these particular questions, if you don't know Pigeonhole principle, how do you think that this is going to solve with the Pigeonhole principle? So you have to think it by the basic intuition also. obviously using the basic intuition you can solve, but obviously you can solve using the pigeonhole principle. The same simple thing is that if you just choose this particular part, you are going to get this. Okay. So this was all about the pigeon principle. Obviously, like in the Rosen book, there are a lot of questions discussed. You can solve a particular question, but this is the fundamental thing that you need to follow. Okay, this is the fundamental thing you need to follow. So the generalized pigeon principle is if n is the object placed into k boxes, then there is at least one box that will contain at least n divided by k. This is the obviously. I think this is the ceiling of the particular function. Okay, so like there is something called this thing and there's something called this thing. Okay, something called greatest integer and this is something called lowest integer. Okay, so this particular means that like this is called the ceiling function. I think you are aware of the ceiling function and floor function. So something like this is written. Let's say it is in 2.3. Okay, so this means that it is being translated to the next possible integer, which is 3. So like this is 100 by 12. This is going to be 8 point something. Okay, so this is translated into the next integer, which is 9. Okay, so this is the nearest integer greater than this particular number, and there's something called this particular thing which is nearest integer less than this particular number. Okay, so this thing you have to keep in mind. So basically if we do 26 by 6, okay, we'll get 5.1 or something like that, or obviously you can translate into the nearest possible integer to get the 6. Okay, so obviously you can solve this particular way. So obviously these are the, that's why this particular smallest integer n concept is there. So this particular symbol you have to understand, it means that if something round number is 10 2.7, it means that the nearest integer greater than this particular thing. Okay, the smallest integer greater than this particular thing. Nearest means on the number line, you can see that. Okay, this was all about the pigeonhole principle.